Welcome back, Mathsy people. This is an important one. We're talking about the remainder theorem and the factor theorem. And the remainder theorem you've kind of already seen, even though you may not know it. It's where we've already sort of established that suppose you've got a polynomial, you can divide it by something, let's say x minus a, to get some sort of quotient answer, and you'll also have some sort of remainder, whatever the remainder is here, so whatever your answer is, plus I guess your remainder r. I'll just represent that as an r down there. It's remainder r. It's a bit of that's sort of how you do it. How it's written is your initial polynomial is actually made up of this dividend, the divisor, sorry, what you're dividing by, multiplied by your quotient answer plus your remainder there. We've also realized that you can actually write this in a different way, which is the polynomial divided by what you're trying to divide by equals your quotient answer plus whatever your remainder is divided by the thing you divided by. There you go. So that's what you've already been doing, and this is what you now know, this solution. And the remainder theorem basically, as I explained on the other video, says, what if I put a in for x? If a is in for x, it becomes a minus a times quotient of a plus your remainder. A minus a is 0, so this entire term falls out. Now your polynomial of a gives your remainder. So to find your remainder, you just need to put a in, this value here, or over here, it's written there, and that will give you your remainder. Now, so that's the remainder theorem, and I'll go into that in a bit more detail in one moment. First, the factor theorem is a little bit of cleverness, which is having this term is a bit ugly and a bit annoying. It would be much better if we didn't even have it, if that wasn't there. The only way that cannot be there is if the remainder is 0. So what we want the remainder to be 0. So for the remainder to be 0, we need the polynomial with respect to a to equal 0. So how do you do this? Well, often you just do it by trial and error. Try different values of a in the polynomial. Whenever you get an answer of 0, then you know that x minus a is a factor. X minus a is a factor, and it's a good thing to divide by. So that's sort of the factor theorem. You may not fully get it, perhaps, until we do an example. So let's give one a crack. Let's just have a look here. Alright, let's have this equation. X cubed plus 4x squared minus 11x minus 30. Okay, so this will be our polynomial, p of x. That's cubed. Okay, polynomial of x is this polynomial here. And so what we want to do is find some value of a, so when we evaluate it, the answer is 0. So let's try something simple first. Let's try 0, just to see what happens. So 0 cubed is 0. 4 times 0 squared, that's 0. Minus 11 times 0, that's 0. And then minus 30. So minus 30. Now that does not equal 0. So it's a bad choice choosing a is minus 30. So let's try something else. Let's try 1. If we try 1, we've got 1 cubed, so that's 1. 4 times 1 squared, that's 4, minus 11 times 1, minus 30. Now that is, well, we've got 5, so that's take away 11, that's negative 6, take away 30, negative 36. That's obviously not going to be 0 either. So suppose we try a few more things, and let's try as one of our options 3. So 3 cubed is 27 plus 3 squared is 9, 4 times 9, 36, minus 11 times 3 is 33, minus 30. So you can see if we put 3 of the 36 onto this, then we have 30 and 33. So that actually does indeed equal 0. So what that means is, as a factor, we should try x minus 3. Because our polynomial with respect to 3 gives us 0, so the remainder will be 0. Our remainder term will be 0 if we try x minus 3. So now let's factorize this quadratic here that we had. So here it is, our polynomial. Oh, so it's a cubic, I mean. For x minus 11x minus 30. And we've decided a good choice is x minus 3 because it will give no remainder according to the factor theorem. So then we'll go, how many x minus 3's are there in x cubed? There's x squared of them. X squared times this is x cubed minus 3x squared. Subtract away 7x squared plus, let's drop this term down, minus 11x. How many x minus 3's are there in 7x squared minus 11x? Well, there's 7x of them. So 7x times this, 7x cubed, 7x times minus 3, minus 21x. 11x minus negative 21 gives 10x. Drop our final term down, minus 30. How many x minus 3's are there in 10x minus 30? There are 10. 10 times this, 10x, 10 times minus 3, minus 30. Do a subtraction. The remainder is 0. That's just like we expected. So here we go. This cubic here, x cubed plus 4x squared minus 11x minus 30 is equal to x minus 3 times x squared plus 7x plus 10, our answer here. So there we go, and that's why it's called the factor theorem, because it finds this factor here, x minus 3. It's found that factor. Now you will of course notice that this is just a quadratic here, and if you use the thinking about it method and know that factors of 10 include 2 and 5, and 2 plus 5 is 7, you know that this bit here can be factorized into this. So our overall, if you want to fully factorize the whole thing, it's x minus 3, x plus 2, and x plus 5. And the whole thing has been factorized, which is really, really handy. Okay, there's just one last little thing, which is make sure you have a look at this. It's x minus a, and we've done like x minus 3. Now in the last video, we did this one example where we divided by 2x minus 7, and that does not look like x minus a. It's not x minus a, it's 2x minus 7. So we can't use the factor theorem stuff here. The only way you can do it is if, well, there are two different options. One is you can take out the factor of a 2, so 2x minus 7 equals 2, and then x minus 7 on 2. So you could do it like that, and A is now 7 on 2. So that's one option. The other option is, so remember our result that P of x is, so now let's change it now to, say, bx plus c times q of x plus remainder. Okay, so now this is in the form 2x minus 7. So what would we have to put in for x for this to be 0? Well, if we want this to be 0, then we can rearrange and say that we want x for, let's do this a bit cleverly, for bx plus c to equal 0, we need x to be minus c over b, minus that number over that number. Then then we can use our remainder theorem. So we can say that p of negative, whatever that is, c over b. Oh, maybe this would be a whole bunch easier if I just put this as an a. Make that an a. A over b. Polynomial of a over b is equal to the remainder. This is handy because, yeah, so we'll leave it like that. If you want to get rid of this negative, that you could make that a negative and that a positive. It doesn't really matter too much. So let's do it for this. No, let's not do it for this case. Okay, so there's that extra little tidbit of information, if you like, which you may or may not need to use. Alright, I might just end that video there. Lots of people probably have some questions about that, but you might have to just come and see me if you want a further explanation of that one.